Audio Jungle.
What do you mean by the operating system? The operating system via hardware and the user interface, via keyboard, via and whatever we type that's been interpreted internally by the OS, right? So this we already know all these things, but this is very basics. So why Unix? Why not Windows? I mean, why people are moving towards the Unix OS rather than, they can easily work on the Windows, but why Unix? Unix is one of the strong operating systems, and all the e-commerce or the banking sectors, they use Unix because it's highly portable, it's highly secure, multi-user, multi-portable. You know, if 1,000 users are logged into one single Unix machine with the same IP address, Unix is very much capable of handling all the users. But at the same time, if you try to log into Windows machine via your MSTSC or RDB control, the machine will break because it's not very stable. It cannot take so much of load. So Unix is very, very strong. It's being developed by Linus Torvalds earlier in 19 some. I mean, I don't remember the year. And later on, people started using, since Unix is the open source. So what do you mean by open source? So let's go to the history of the Unix. So I've just opened a website called as tutorialpoint.com. So in my PPT, I don't have the theory available, right? The architecture. Basically, there's a concept called as the kernel and the shell. So do I need to discuss the kernel and shell? What kernel is, what shell is? Or you are already aware of it. About the architecture of the Unix. So there's something called as shell and there's something called as kernel, right? So what is kernel and what is shell? So I opened this terminal in front of you, right? So this is my Unix terminal, right? I can write any sort of commands. I can do anything here, right? So what this shell means. So on the terminal I am working, and this is our shell. So shell is nothing but it's a command interpreter. So whatever user writes, or whatever your engineer or whatever any person writes on the screen, that's been interpreted by the shell. And in the backend, it is understood by the kernel. So our computer understands the language of 0 and 1, right? But being a human, right, we cannot remember 0 and 1, and we can write in the binary language. So there's something called as human language on which we write our tasks, our commands, our scripting, our programs, or anything, and that's so. Whatever we are writing on the shell. So if I need to check on what shell I'm working on, right? So I'll just type echo follow shell. So echo is equivalent to a printf in the C language. $shell is the variable. That's the defined variable for the Unix, which contains your shell name. So let's say I wrote a command ls. It gives me some output. So how it happened? I mean, so I wrote the ls on the shell prompt. So shell recognizes, okay, user has given the ls command. In the backend, it sends a command to the kernel. Kernel converts this command into machine language, right? It processes with the CPU and the memory, gives output back to the shell. So that's how, it's a very basic of the Unix, shell and the kernel architecture. So if I talk about the Unix architecture, this is how it shows. I mean, and this is the shell, right? This is the kernel, and this is the hardware. And all the commands are whatever we are typing on the shell, right? That's being sent to the kernel. Kernel processes within the CPU, and sends back to the shell again. Shell is basically it's an interpreter between the user and the hardware. Discussed with you, right? Architecture we already saw. Okay, so what is the file system basically? So Unix file system is one of the file systems for the Unix OS. but generally when you speak about file system, what it is exactly. Okay, so we were discussing regarding the file system, right? So file system is nothing but it defines how your information. This you are storing the information on your operating system, right? You're storing your files, your programming scripts, you're storing your video files or the audio files. So you're storing all these things in your operating system. So there has to be some way by which your storage structure has to be managed, right? So file system defines how your information or the uh, how your information has to be stored in your operating system, correct? So let's say, so are you aware which operating system, which file system we use in the Windows? So generally, when we install the Windows operating system, so what file system are we using in that?
Windows
So
Explorer?
by default, it comes by, sorry?
Is it Windows Explorer?
No, that's the web browser. So if you go to the Windows properties, right? So you'll find NTFS. So NTFS or the FAT32, that's the OS, that's the file system we use in the Windows. But in the Unix, there are multiple file systems like the ext2, ext3. So if I open the page again, I go back, you know, so firstly, everything in the Unix, it starts from the root, right? So you might be aware of this. So if I need to check what file system I'm using in this, right? I'll just give a command called as df-k, right? So it says this is the file system. So are you aware of this command? So it defines all your partitions, the way we have the partition in the Windows, C drive, D drive, E drive and all, right? So we have the partitions defined in the Unix when we install the Unix OS. It is mounted on this. So the mounting means these are attached. So these are equivalent to a C or D drive in the Windows. If you go back to a Windows OS, you normally see C drive and D drive, all the partitions. So here the partition is like, so in Unix everything is a command line firstly. So we are not clicking and it's not GUI, it's all command line. So everything in the Unix it starts from the root. So we call this as a root directory. So under root we have everything available. So all the subdirectories or all the files, they are actually residing under root directory. So this is the file system we have, right? On this file system, so we have created all these partitions like //dev shm /boot and all. Okay. No, my concern is we see /dev sd1 and all. So any idea what you mean by this? Have you ever ran this command and saw on your Unix screen?
/dev/sdl or
Yeah, this one actually.
no idea.
Okay. So SD1, so we have different sort of hard disk, right? So all our partitions, all the information is stored on the hard disk. So SD1 is one of the hard disk, right? So all the hardware, let's say it can be a pen drive, it can be a floppy drive, it can be your hard disk. They are stored under /dev, right? So when we try to access anything in the Unix, any device, so it has a device file under /dev. And using that device file, we are accessing our hardware. So SD1 is one of the type of the hard disk available in the market. So in my system, I am using SD1 right now. So it is showing SD1 as one of the hard disk. Correct? On this hard disk, I have created a partition called as /boot. So when you install the Unix, it gets automatically created, but for the understanding purpose, I'm telling you scripting, right? So let's start with the different types of the files. So So any idea how you create files in the Unix? So I want a cross communication, both of you, please. Yeah. So that I'll feel happy while teaching.
We can
So
do
how
via
to create files in the Unix?
we can do via
What
VI.
command we use for that?
VI we can use.
VI. Okay. Any other command? So VI is basically it's an editor by which we open the file. So we use a command called as patch. You know. So before we go with the commands, I would like to specify a few things. Like if I need to check in which folder I am, I'll use a command called as pd. So it says I'm under /root. So I'm under /root directory. If I need to list all the files under /root, I'll type a command ls. You know, if I need to, so in Unix, everything is a commands. In every commands, they have different options available. So ls command I have typed first, I got the output. Now if I want more refined output, I'll type ls -l. So all the options with the commands, they are prefixed with the -hyphen sign. You know, so if I type ls -l, it will show me all these things. So are you aware of the permissions on the files and directories?
Yes. Yes, Jayant, I have a basic idea on those commands.
So I would like to discuss the permission on the files and directories, right? So if I type ls -l, it will show me all the files and directories under my present working directory, right? So PWD means present working directory. I'm working on this particular path right now. Under this, I have all these files and directories available. Correct? So these are
Yes.
the permissions. Yeah. Any doubts? So these are all list of all the files and directories, right? On the right hand side. And if it is the permission are starting with D, that means this is a directory. If it is not starting with D, that means it is a file.
Okay.
Unix, right? So what I'll do is I'll do this once again. You know, so I'm under a path /root. You know, so we will be let's say if you're working on any project, so what we do is we save our files in one particular folder which we create. So let's create one of the directories under which we'll be creating all the files, scripts in directories. So let's say Unix underscore training. So this is a folder which I create. I use a command called as cd, change directory, to go inside this particular folder. Okay. So I'm under the path /root /Unix underscore training now, right? Now if I need to create a couple of files and directories under it, so I'll use a command called as patch file1, file2, file3 and all. So if I do ls -l, I'll see all these files under this path. Because I created all these files, let's create some directories now. Let's say dir1, dir3. Let's create 3 directories. So if I do ls, I'm getting this output. If I need output in long format, I use ls -l. So you can see here all the directories, their permission are starting with D. So D specifies, okay, this is not a file, but it is a directory, right? This is the time on which all these files or directories got created. This is the creation time. This is the date. This is the size of the directory so far. You know, this is the root. So here root is the user of the directory, and this root, this says it is a group. So the group owner and the user owner of this particular directory is root and root, right? And these are the permissions, and this is the link count. So I'll come to the link count later on. So let's discuss on the permissions first. So any one of you, if I ask you what are the permissions on the file F1, so if you have any idea, you can just tell me so that I can understand how much you know about the permissions and all.
Read, write are the only permissions there.
Okay, so read and write is for the user, right?
Yeah.
And read is for the group, and other read is for the others. So this
Others.
file has this permission. So from where this permission is coming actually? Since I am creating a file or a directory, so by default these permissions are assigned to it, right? So these are the permissions which are by default assigned to file F1. So there's something called as umask in the Unix. Umask, right? So it says 022. So umask is nothing but we are masking or hiding the permissions. So by this command you can just understand umask is basically to hide the permissions on files and directories. So by default in Unix, permissions are for the files. It is for the files, it is 666, right? And for the directories, it is 777. So we are talking about the octal method of the permissions on the Unix. So I'll come to the octal method. So by default, we have these permissions assigned to the files and directories by default, right? Now, if I need to check the octal value or the octal permissions, for the file F1, so read and write. So if I come here, if I type read, write, and execute. So these three permissions we have on the file. So read in the Unix, it is denoted by 4, a numeric 4. Write is denoted by 2. And execute is denoted by 1. Right? So you both are clear till now?
Yeah.
Yes.
All right. So the read permission is denoted by 4, write permission is denoted by 2, and execute permission is denoted by 1 in the Unix, right? So if I check this permission now, let's say this is the permission which I have. Let me copy this on the notepad. Okay. So what it means is for the user we have permission 4 and 2, right? Read is denoted by 4, write is denoted by read is denoted by 4 again. So the actual permission on this file is 644, right? 4 plus 2. So for the user it is 6, for the other group it is 4, and for the others also it is 4. So so we spoke about the umask, right? So what umask is, it is hiding the permission. So by default the maximum permission should be 666, but since the umask is set as 022, so by default when we are creating any file in the Unix, we are getting a permission 644, correct? And what about the directories? I mean, if I talk about the default permission which we have for the directories right now, so they are. So can anybody can tell me what is the permission on the directory right now by default in terms of the octal value?
Okay. 4,
So for
2,
the user,
1.
it is, yeah.
4,
Okay.
2, 1, 4.
So it's 7 for the user, right?
Yeah.
What about the group?
5.
Correct. And same for the others also.
Yeah.
By default maximum is 777, but since we have the umask 022, so it comes at 755. So so by umask means we are hiding the permissions. So why we need to hide a permission? That is for the security purpose. I mean, that's the only reason we hide anything, right? So we need not to give the permission so that a particular person, or let's say Unix person or the DBA or the Java person, he should have a limited permission, what he requires for his project. So we can change umask, like if I change umask to, so right now my umask value is 022. So the first 0 is for the sticky bit. So we are not more concerned about it right now. So we can change a umask, let's say 000, right? So now my umask value is 000. If I create any directory now, dir, let's say test, let me create any file, let's say file underscore test. So by default, this file and directory, it should have a maximum permission because I'm not masking anything, right? So dir test, which I created, it has all the permissions. You can see here. For the user, it is read, write, execute. Same for the group, same for the others. And for the file, it is 666. Read, write, read, write, read, write for user group and others. So I hope till here it is clear to you. Device files. So the regular files are nothing but they are the files which we create here, right? Directory files are nothing but when we create any directory using mkdir. So the permission part is preceded by D. And what is device files? I mean, I spoke about device files earlier. So device files are nothing but let's say you inserted a dongle into your laptop, or you inserted a pen drive into a laptop, or you inserted your let's say USB cable. So how your computer or the Unix OS detects. So for everything in the Unix, for every hardware, whatever you need to access, it has a device file created under it. It's available. So if you want to open a car, right? So you have a key to access the car. Without key, you cannot open a car. In the same way, when you need to access any device from the Unix OS, so by default, it has the device files present for it. Let's say floppy drive, right? So if you need to access a floppy drive, you have this particular device file, right? If you want to access a DVD, so this is a device file. So internal, obviously, it contains a lot of coding. So everything in the computer, that's a coding internally, right? But we are not concerned, we are not creating any code for it. If you want to create any connect any pen drive, simply a device file will get activated and you can access the pen drive. So CD-ROM, again, you know, for CD, for DVD, for floppy drive, for hard disk and all. So you have a device file present in your Unix OS. Simple. So for accessing a hard drive, right? So since we are storing the information, let's say I create a file called as GG. So this file is getting stored somewhere on the hard disk. So to access the hard disk, you have a device file present. If you want to mount anything, repartition, if you want to format your hard disk, so what you will do is you will go to /dev, you will go to, so, and this is the device file for your hard disk. So we call, so whatever we are accessing via hard disk, those files are called as block device files, because your information in the Unix, they are stored in form of the your blocks, right? So under blocks you have different multiple bytes available, correct? So in the form of blocks, your information gets stored in the Unix. So any one of you is aware of the inode number, what inode number means? Have you ever heard of the term inode in the Unix?
No, not from my side.
So inode number is similar to the pointer in C language, correct? So so what pointer means? Pointer is basically, it defines the location where your particular information, your file or directory is stored, right? So let's say I go back to the directories of the files I created. Let's say I have Unix underscore training. So if I need to see the inode number for respective files and directories, along with the L option, I can give I option. So I specifies inode number. So these are the inode numbers. So whenever we try to access any file in the Unix or any directory in Unix, so your inode number tells, okay, this is the location where your this particular directory is stored. You know, so it's a pointer location. Okay, this you're trying to access this file. This is the address. So if you want to post a card or anything to your relative or friend or family, right? So you write the postal code and all these things. So it's similar. I mean, uh, so this is the pointer location to your information. Simple. So we discuss about these things.